So it's always interesting following such a great storyteller and speaker like Len. And I'm going to talk a little bit about something biological, something completely different than what we've just heard about over the last few talks. And if I can find the right button, here we go. I'm going to ask a question, and then I'm going to ask two questions, really. I'm going to ask you, why is it important to restore seagrasses and seagrass meadows, and how we can do it. And this is sort of, we live in a world where the messages we're getting are all about loss. The Great Barrier Reef is all going to die on you. The world of the mangroves is dying at great rates. The seagrasses are the same. But really, unless we take responsibility as a community and do something about the losses, and one of the ways we can do that is with restoration and with amelioration of our impacts, then we as a community of scientists are really not helping the problem, we are the problem. So with that sort of little philosophy of mine, I'd just like to walk you very quickly through about 10 slides. So, firstly, what do we like about West Australia? Firstly, most people know about Ningaloo Reef. Some of you may know about the beautiful coral reefs at Abrolhos Islands. We all love our temperate reefs and our seagrass beds over at Rottnest Island. And Shark Bay is an icon, even if it's unexplainable, or it's so large it's hard to get an actual view of it when you just go and arrive on its shore. And that large, shallow bay is created by seagrasses. And recently we looked at the amount of buried carbon in the system, looking at blue carbon as a potential economic benefit, blue carbon being seagrasses, mangroves and salt marshes. And we came up with a figure of $80 billion of carbon is buried in that system. So huge amount of value, both in storage, in a world where carbon is an issue. And that's what seagrasses are to me. They're quite an amazing thing. They're basically a flowering plant. They occur submerged, they flower submerged. Their flowers are actually quite beautiful. And we're lucky here in West Australia. We're incredibly lucky because we're at the site of temperate biodiversity in the whole world. There are only 72 species of seagrasses in the whole world, and we have 21 species off the coast of West Australia. So 21 of the 72 species are found here, and of those, half of them are endemic. So yes, it's not the thousands of beautiful angiosperm flowers we have on our terrestrial lands, but the same effect is happening underwater. We're a global hotspot here, and for that reason, we've got to take responsibility for it. The other really cool thing about seagrasses, they're a biological sentinel. They're basically the canaries and the coal mines for our coastlines. So seagrasses don't like not getting enough light. They need 10 to 100 times more light than the seaweeds do. So they're actually very, very good at picking up on pollution, picking up on contamination, and picking up on poor light environments, basically. Dredging, stuff like that. Unfortunately, that means the trends globally are negative. If you look at this all these pie charts, you'll see the red is the bright and the dominant colour. And those are the decreases globally back in 2006 of seagrasses around the world. 58% of the studies we looked at were actually decreases in seagrasses. And it got a bit worse than that. The scale of loss. We sat around the table one night over pizza and tried to come up with what's a understandable amount of scale of loss. Every half an hour, or every 30 minutes, every half an hour, we lose a soccer field of seagrasses globally around the world. Okay, it's just gone. And this is since the 1980s. And that's just not us doing some fancy maths and coming up with some really nice figures to show people about how bad the world is. If we just take one local example, Coburn Sound. Everybody knows Coburn Sound, I expect. Do you? Beautiful place. Well, when we formed the outer harbour in Coburn Sound, this is the sort of distribution of seagrasses, both on the eastern and western banks, the southern shores of Rockingham. I remember swimming over it as a child, that horrible green stuff that you try to not touch because it felt horrible on the legs. Right, 1973, we start to lose it on the eastern banks and the southern shores. By the 1980s, we've literally lost 77% of all the seagrasses in that system. Over 800 hectares were lost. And it was caused by a little bit of us not thinking about the world we live in, and subsequent to the 1980s, we've been looking after the system very, very well. But we're still losing seagrass. And partly that's because it's an enclosed embayment, it's the site of large urban developments, but it's also the site of our port and our major industrial area, Coburn Sound. But we think we can fix it up. How do you deal when you lose seagrasses? Well, basically you go out and replant them. Much like you replant a lawn, they're a monocot, and much like lawn, you can plant these rhizomes and they can grow. We had a look at all of the programs around the world in seagrass restoration just recently, and we came up with this map. Just look at the green dots. You'll notice that the green dots are where the red pies were before. So a lot of effort is going into us trying to understand how to recover these already lost systems. And about 55% of it's just done by vegetative fragments or rhizomes, or what you'd pull out of your lawn. But the problem with doing that, and this is the issue really, is that it's really easy to transplant a lawn, but it's very, very difficult to transplant thousands of square kilometres using that same method. So here's to just give you an idea. This is how we do it. I won't walk away from here. There's no red light. But basically, if you look at the top image, there's a whole pile of pieces of lawn attached to a couple of pegs. You push it in the ground, you leave it there, and over time it'll grow into squares. I'm sorry, but they're squares of Seagrass Meadows. It's a widespread practice around the world. 55% of all the programs do it. It costs a lot of money. That's 3 times the cost of doing the same restoration on land. So $33,000 to $3 million per hectare. Now, if we've lost 800 hectares in Coburn Sound, this is not the way to do it, because we don't actually have that sort of that economy. It's a misscaled approach. It's a very useful combinatory approach with other methods, but it's just not the way to go. So at UWA, we've been playing a lot with this seed-based approach for restoration on land and now under the water. And we've been working with Robert Orth now for about 6 years. And the really cool thing about Robert's work, he's a pragmatist. And in the USA, in the state of Virginia, he's transplanted over 1,000 hectares of seagrass using seed-based methodologies over a 10-year period. He was told for many years it wasn't going to work. He just did it. And how he did it is he just went out, collected the seeds, treated them, he evaluated the condition of them, he stored them, and then he made sure that the dormancy was broken. He put them out into the field. This went from May to November, and then by the next year, he had a whole pile of new plants, and by the end of that year, they were reproducing and producing seed naturally into the system. So he actually is responsible for about 1/100th of the total growth of seagrasses in that area. But that's directly responsible. So we tried it here with Postini Australis, beautiful plant. I'm going to step away from here. They're all fruit. Postini Australis produces millions of fruit which get blown around the ocean and feed animals, but generally don't create meadows. So what we're trying to do is collect the fruit, and we put it into vats down at the university's greenhouses, and we get the seed out of them. The really cool thing about Postini is that it doesn't have a dormancy stage. So we can get these seeds within 2 weeks and actually plant them out in the field straight away. It does mean one problem though. you've got to have a lot of staff working the month of November, pretty much, 24/7. Sometimes it doesn't work, but that's what we're trying right now. And what we're finding in this picture, the grey blades are actually dead leaves, and they congregate in the shallows in sort of February, March. But the green ones are actually 1-year-old transplants. And if you just look at that, this was going to be a video, but I couldn't transfer the video, so we'll just look at this image. There's actually quite a lot of regrowth there. So now we know that we can actually broadcast seeds over quite large areas and get success. So what's the next step? And I don't expect you to read all this, but we're now building a case for, I think we've built the case. It basically costs us $1,000 to $5,000 a hectare to do this sort of work versus the $33,000 to $3 million a hectare to transplant. And what we have to do now is prove that case in a much broader scale. We're in the process of building community awareness. You might see some ads coming out in newspaper, especially if you're down around Rockingham. We're in the process of trying to either get a big program going this year or next year. We're looking for volunteers, especially volunteers with boats, to sow our seeds, basically. And we want to build a community awareness and a capacity for us and a confidence that we can actually treat these degraded marine environments in such a way that we can repair them. Also, we want to build this experience with the practitioners that will take this commercially further, and also affected the policy framework that allows this sort of work to go ahead. So that's all I was going to say, except that these ones here are 4-month-old seedlings from this year. So this is my March picture from this year. And just to thank all of the partners, including the partners that will take this idea further, like BMT Oceanica, and just to show that we have a lot of fun out there as well. So, any questions?